Creating math by using algebra tiles. Why do we need to concretize math? The more senses are exposed, the better the learning. Avoiding math anxiety, trend in world's math learning, making math a fun experience. Algebra tiles are known as mathematical manipulatives and can be used as an instructional material that allows students to better understand ways of algebraic thinking and the concepts of algebra. Algebra tiles. These are tiles made out of wood, cardboard, or other flat materials. These tiles are best used to illustrate algebraic operations. Types of algebra tiles. First is the 1 tile, represents positive 1 or negative 1. The red one represents negative 1. X tile represents a first degree variable, usually positive x or negative x. X squared tile represents a second degree variable, usually positive x squared or negative x squared. Adding integers or signed numbers. Rows represent the addends with 1 tiles. 2 tiles with different colors are called zero pair. We always remove all zero pairs in when we add integers. After removing all zero pairs, count the number of tiles left. This number is the answer. The color of the remaining tiles tells you the sign of the answer. Remember that red tiles always represent negative number. Other than red, all the tiles represents positive. Example, adding positive 6 and positive 2. First represent positive 6, and then represent positive 2 using the tiles. Move all zero pairs if there's any. And as you can see, there are no negative tiles, so there are no zero pairs. Count the number of tiles left. Identify the sign of the answer. First, we will count the number of tiles left, and the number are 1, 2, 3, 4, 5, 6, 7, and 8. And identify the sign of the answer. And since the tiles represent positive, all, we can conclude that the answer is positive 8. Next example, adding negative 5 and negative 12. First represent the negative 5 and then represent the negative 12 using the negative tiles. Remove all zero pairs if there's any. And as you can see, there are no zero pairs because they are all negative tile. Count the number of tiles left. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Identify the sign of the answer. As all the tiles represent negative tile, we can conclude the answer is negative 17. Next example, adding positive 7 plus negative 4. First, represent positive 7 using positive tiles, and represent negative 4 using negative tile. Remove all zero pairs if there are any. As you can see, there are pairs of negative and positive tiles, so there are zero pairs. Here's the first, remove, second, remove, third, remove, and the fourth, remove. And the number of tiles left, 1, 2, 3. Identify the sign of the answer. Since the tile represents positive integers, we can conclude that the sign of the answer is positive. The tiles left is 3, therefore the answer is positive 3. Example number 4. Positive 9 plus negative 14. Represent positive 9 first and negative 14. 14 negative tiles. Remove all zero pairs if there's any, and as you can see, there are zero pairs. Here are the zero pairs. Another. And last. Count the number of tiles left. 1, 2, 3, 4, 5. Identify the sign of the answer. Since the tile represents negative tile, we can conclude that the sign is negative and therefore the answer is negative 5. Next use of algebraic tiles is subtracting integers. Rules. Represent the minuend and the subtrahend with 1 tiles. Change the sign of the subtrahend if the tiles are red. Change them to any other color, or vice versa. Remove all zero pairs. Count the number of tiles left. Identify the sign of the answer. Example number 1. Positive 6 minus positive 12. Represent positive 6 first. 6 tiles because positive 6 tiles. And another 2 positive 2 tiles. Change the sign of the subtrahend, the second one. In subtracting integers, we always change the sign of the subtrahend or the second one. Then, remove all zero pairs if there is any. And as you can see, there are zero pairs here. We will remove them. Count the number of tiles left. 1, 2, 3, 4. Identify the sign of the answer. Since the tiles represent positive, we can conclude that the sign of the answer is positive. Therefore, the answer is positive 4. Example number 2. Negative 5 minus negative 12. First represent negative 5 and negative 12. Change the sign of the subtrahend, the second one, from negative to positive. Remove all zero pairs if there's any, and as you can see, there are zero pairs in the tiles. Here are the zero pairs. We remove them. Count the number of tiles left. 1, 2, 3, 4, 5, 6, 7. Next, identify the sign of the answer. And since the tiles represent positive tile, we can conclude that the sign is positive, and therefore the answer is positive 7. Next example, positive 7 minus negative 4. Represent positive 7 first and negative 4. Change the sign of the subtrahend, the second one. And as you can see, they are both now positive tiles. Remove all zero pairs if there's any. There are no zero pairs because there are no pair of negative and positive tiles. Count the number of tiles left. 1, 2, 3, 4, 5, 6, 7 from the upper. 8, 9, 10, 11 from the lower. Identify the sign of the answer. Since all of the tiles represent positive, we can conclude that the sign of the answer would be positive, and therefore the answer is positive 11. Example number 4. Negative 9 minus negative 4. Represent negative 9 first and negative 14. Change the sign of the subtrahend. Remove all zero pairs if there's any. These are the zero pairs. As you can see, there are many zero pairs removed. Count the number of tiles left. 1, 2, 3, 4, 5. Identify the sign of the answer. Since all the tiles represent positive, therefore, the sign would be positive and the answer would be positive 5. And that is the use of algebraic tiles.